Hello everyone. In this video, we'll be talking about a special case of free fall when the objects are thrown vertically up. So, as usual, take out your notebook and pen, and wherever you require, you may pause the video for making your notes. In between the video, you'll be getting few checkpoints for conceptual practice, and their answers can be verified at the end of this video. In the beginning of the video, we'll derive few important relations and then we'll be taking up numerous good questions. Okay, so let's begin. Suppose a ball is thrown up from the ground. Its initial speed is u and it's projected straight up. Then we want to determine in how much time it will ascend to its maximum possible height. That answer will be u by g. Similarly, the time of descent will also be equal to u by g. The time of flight will be equal to 2u by g, and maximum height will be u square by 2g. These are our targets. We'll derive them one by one. So this ball is rising up and slowing down. Here comes a moment when the ball attains its maximum possible height above the ground. At this moment, its velocity is 0 momentarily. Okay. For computation purpose, we are choosing the upward direction positive, the downward direction to be negative. Acceleration due to gravity is in this direction. Now, to travel up this height, let's say it is consuming the time of ascent. Okay. In order to obtain this time, we should use which equation of motion? Simple. We can directly use the first equation of motion. V is equal to u plus at. So V is 0. Then U is u only. Acceleration was in downward direction, so negative sign, and time of ascent. This computation will give you the time of ascent is equal to u by g. This ball will fall back to the ground, and we know by the symmetry the speed while hitting the ground will also be u only. So for the downward journey also I am using the first equation again. Ball starts from here. Actually it will go along the same line. For sake of the derivation I am showing it a little bit displaced, and then ball will speed up. So using the first equation, now the velocity is also in the downward direction. So check it once. The time of descent comes out to be u by g. We have derived it. Now the total time of flight starting from this level and then reaching back to the same level can be easily obtained. Total time of flight will be equal to time of ascent plus the time of descent. The time of flight actually means the time for which the ball remains in air. So when you simplify, it comes out to be 2u by g. Then we need the last data, the maximum height obtained. For maximum height, we can use the third equation of motion. So for upward journey, the final velocity is 0. So 0 square, initial velocity is u plus 2 into minus g into h. And when we do the computation, the h will come out to be u square by 2g. Simple and easy formulas. If you learn them, it will make your calculations quick in many questions. For example, suppose I throw a ball up with the speed of 30 meters per second. In how much time it will reach to its maximum height? The answer will be u by g, 30 by 10, 3 seconds. In how much time it will fall back to the same level? Then the answer is again u by g means 3 seconds. For how much time it remained in air? So that answer will be 6 seconds. Okay, time of ascent plus time of descent. How much is the maximum height of that ball? 30 square by 2 into 10. So 45 meters. I hope you understand the things. Now, there are few symmetries. Suppose at this level, the ball is going up and its speed is u star, let's say. Then while falling down at the same level, the speed will be u star, that we call as the speed symmetry. At a given level, the speed while going up and while coming down, they are equal. Velocities are not equal. Velocity is a vector quantity. Here the velocity is directed upward, here the velocity is directed downward. The speeds are same. And another important thing, starting from this level and coming back to the same level, if someone asks you how much time it will consume, it will be 2 u star divided by g. Suppose here the speed of the ball is 10 meter per second. Then coming back to the same level, it will consume the time 2 into 10 divided by 10 means 2 seconds. Okay, note it down, and then we'll be taking up a few important graphs. Here is the first question of the video, and it's a simple one. So I request you to pause the video here and give it a try yourself. Then I'll be simplifying all the parts. I hope you are done with your calculations. So let's check up the answers. The first part, the time of ascent will be equal to u by g, which will be equal to 30 by 10 means 3 seconds. I hope everyone agrees with that. Second part, the time of descent. Can we use here u by g? What do you think? The answer is no, because now it's not landing at the same level. It's landing below the projection level. It is hitting the ground. So we need to calculate it. For calculation purpose, let's draw the diagram. Suppose this is the tower of height 80 meter as given in the diagram. T is equal to 0 is the moment when we project the ball up. Its speed is given as 30 meter per second. For calculation purpose, upward direction we are taking as positive, downward we are taking as negative. Acceleration due to gravity in the downward direction has been taken as 10 meter per second square. Okay. Ball will rise up and somewhere it will attain momentarily rest. This height, let's say we call as h. How we can compute that h? This is simple. H is equal to u square by 2g. Above the projection level, if we want to calculate the h, it will be equal to 30 whole square divided by 2 into 10. So that comes out to be 45 meter. While doing the calculations, I am putting everything in the SI units. To make the calculations faster, I am just putting the final unit at the end of the calculation. Okay. Now, this ball will fall from a height of 125 meter while reaching back to the ground. Do you agree? It will start from here. 45 meter plus 80 meter means 125 meter. Falling back to a distance of 125 meter, it will take how much time? Root 2 into 125 divided by 10 means 5 seconds. You remember I used which formula? If something is released from a particular height, then time is root 2h by g. There is a complete video on the topic when the objects are released. The formula has been derived in that video. So I am utilizing it from there. Third answer, we have already obtained the 45 meter. Now the fourth answer, if someone asks you what is the maximum height of the ball above the ground, that answer is 80 meter plus 45 meter, which is equal to 125 meter. Is it okay? Fine. Now, what will be the hitting speed of the ball? For that also we have the formula. V is equal to root 2 into 10 into, it is falling from a distance of 125 meter. We can do this computation. It will come out to be 50 meter per second. So when it will fall back to the ground, it will be hitting with the speed of 50 meter per second. Is it okay? Now the last part of the computation, all the graphs, will plot them one by one. The first graph is the position versus time graph. the position versus time graph will be a parabola, mouth opening downward, because the acceleration has a negative sign here. I am proving that. Suppose at any time t, we write its position as y. Okay, then y will be equal to what? 30t plus half of minus 10t square. This equation is a quadratic equation. There is a square term with the time, but the coefficient of the t square is negative. So the position versus time graph will be a parabola, mouth opening downward. Suppose here I set up the origin. It means at t is equal to 0, the y coordinate will be 0. Okay. Then at t is equal to 3 seconds, the y coordinate will be maximum, which will be equal to 45 meter. And at t is equal to 3 seconds, the velocity will become 0 momentarily. How we obtain the velocity from the position versus time graph? Simple, using the slope of the position versus time graph. You check it yourself. At t is equal to 3 seconds, how much is the slope of the position versus time graph? 0. Okay. Now, after t is equal to 3 seconds, it will fall back toward the ground. And t is equal to 6 seconds. Will it be at the same level? Do you agree? So at t is equal to 6 seconds, since the initial and final positions are same, so the displacement of the particle will be 0, or you can say the y coordinate of the particle is 0. You can check it with the graph. T is equal to 6 seconds. The y coordinate is 0 as well as the displacement is also 0. Now, after that it will fall further down, and this moment will be t is equal to 8 seconds. Okay. T is equal to 8 seconds. The y coordinate of the particle will be minus 80 meter, or the displacement of the particle is also minus 80 meter. So the first graph indicates the position of the particle at any moment of time as well as the displacement of the particle at any moment of time. Is it okay? Now, taking up the second graph, the distance traveled versus the time graph. 0 to 3 seconds, the particle is moving away from its starting point. So the position's value is continuously increasing and the distance traveled is also increasing. So 0 to 3 seconds, the position versus time graph and the distance traveled versus time graph will be identical. After t is equal to 3 seconds, the position of the particle is decreasing up to the moment t is equal to 6 seconds. But the distance traveled for a moving particle can never decrease with the time. So what we do, we take the mirror image of the position versus time graph after t is equal to 3 seconds for obtaining the distance traveled versus time graph. Is it okay? Then there comes the velocity versus time graph. Velocity versus time graph is very easy. V is equal to 30 minus 10t. So this graph will be a straight line. T is equal to 0, the velocity is equal to 30. T is equal to 3 seconds, the velocity becomes 0. And after 3 seconds, the velocity will be negative. You put here t is equal to 8 seconds, the velocity comes out to be minus 50 meter per second. Minus means in the downward direction. Is it okay? Then we take up the speed versus time graph. Speed cannot be negative. So whatever part of the velocity versus time graph is in negative, we take the mirror image of that part. Is it okay? And last is the acceleration versus time graph, which is the simplest one. Throughout this journey, the acceleration is constant, 10 meter per second square in the negative direction. Is it okay? So it's a simple and easy question. In this question, if someone asks you how much is the net displacement of the particle, then answer is minus 80 meter. And if someone asks you how much is the total distance traveled by the particle, then it will be 45 meter plus 45 meter plus 80 meter. You get it? This distance up to here back is 90 meter plus 80 meter means 170 meter is the answer. Why here distance traveled is greater than the magnitude of the displacement? The answer is simple. Particle has turned back at this moment and then kept on moving. So the distance traveled has to be greater than the magnitude of the displacement. Okay, note it down, and if you have any doubt, let me know in the chat box. Here is the next question, an interesting one. So I request you to pause here and give it your best shot. Then I'll be simplifying it. I hope you got the correct answer, which is the above h by 2. Why? Pay attention. Suppose this is ball A. It was thrown from the ground and it has reached to its maximum height. At this moment, the ball B is thrown up. Okay, let's say its speed is u. This moment we consider as t is equal to 0. So at t is equal to 0, the ball A is at its highest level. Its instantaneous velocity is 0, and the ball B is starting moving upward. Okay, this height according to the question is equal to h. So question is asking where the path of these two balls will cross. Let's say we break it in two parts of height h by 2 each. For this h by 2, if you find the average speed of the ball A, and for this h by 2, if you find the average speed of the ball B, which is greater? Can you tell? It's simple actually. For h by 2 distance, the average speed of ball B will be actually greater than the average speed of ball A. Why? Check the first video of the free fall, the concepts of the free fall. We had a trick there. At the lower altitudes, the speed is always more in such cases. So the ball B is right now at the lower altitude, so its speed is more. If its speed is more, it means its average speed will also be more. Since for traveling this h by 2, it has greater average speed, it means compared to the ball A, it will cover up this distance in less amount of time. So the ball B will reach somewhere here, and ball A might reach somewhere here at the same level. Its average speed is less. So in order to cover up the h by 2 distance, it has to take up more time. It means it is moving slow. So at time t, if I draw the diagram, the ball A has reached here, okay, and the ball B has reached here. Ball B is rising up and ball A is going down. Fine. So the hitting will surely take place at a height greater than h by 2. Okay. Now we can determine this location exactly also. Suppose this ball is falling down by some distance that we can easily calculate. This distance will be equal to ut plus half at square, and half into acceleration is g into t square, because it starts from the rest, so u part is 0. And for ball B, if you want to compute this distance, what you should write? You should write this as ut minus half gt square. For ball, initial velocity is upward, but the acceleration is in the downward direction, so their sign are opposite. What is the relation among these two lengths, half gt square and ut minus half gt square? It's clear from the diagram that h must be equal to half gt square plus ut minus half gt square. This half gt square is getting cancelled out, so we are left with h is equal to ut. You know one thing, if a ball is thrown up with a speed u, then its maximum height h will be equal to u square by 2g. It means we know the value of u. U will be equal to root 2gh. I am submitting that value here. H is equal to root 2gh multiplied with the t. This computation gives us the moment of time. T is equal to root of h by 2g. Okay. Now at this moment, we can determine the height very easily. This distance will be equal to 1 by 2g. At the place of t, I am putting root h by 2g and then whole square. Is it okay? This computation gives us h by 4. So the two balls will cross their path at a level h by 4 below the top point, or at a level 3h by 4 above the ground. This distance is 3h by 4. I am repeating it once again. This ball B has the greater average speed. Since its average speed is greater, so it will cover up this h by 2 distance earlier. It means for sure the crossing will take place at a level above h by 2. Okay. Exact level is 3h by 4 above the ground or h by 4 below the top position. Simple and nice question. You can note it down. Here is the next question and good one. So I request you to give it a try. Then I'll be simplifying it. Okay, I am telling you the answers. The hitting will take place at t is equal to 5 seconds. We are considering the moment when we project the first ball as t is equal to 0. And the height where these two balls will hit will be equal to 75 meter. These are the answers. I am deriving them. Suppose this is the ball 1. The ball 1 is projected up at t is equal to 0 with a speed of 40 meter per second. And from the same point, we are projecting another ball 2, which is projected at t is equal to 2 seconds with the same speed 40 meter per second in the upward direction. So these two balls are actually moving along the same line. For calculation purpose, I am showing the ball 2 bit displaced. It is for sure ball 1 will rise up and will be falling back. At that moment, ball 2 will be going up and these two balls will meet. We don't know the moment when they will meet. Then we can assume, let's say they meet at time t. For all these questions, this is the best way. We imagine the ball 1 and the ball 2. They meet at time t. Okay. If they are meeting at time t, then the height of the ball 1 and the height of the ball 2 above the ground should be equal. Let us write that h1 should be equal to h2. Height of the ball 1 above the ground, we can easily write 40t minus half gt square. Actually, we are taking the upward direction to be positive, downward to be negative. Acceleration due to gravity was in the downward direction. So here we have taken a negative sign with the acceleration due to gravity. Okay. Now writing the data for h2. Speak up in the same way what you should write. For h2, you should write 40 t minus 2 because it was fired 2 seconds later. So for ball 1, if this moment is t, then for ball 2, this moment of time will be t minus 2. Is it okay? Minus half g t minus 2 whole square. It's a simple computation. Now if you have t is equal to 5 seconds, you can easily calculate h1 or h2. The h1 will be equal to 40 into 5 minus half into 10 into 5 square. For calculation purpose, I am taking g is equal to 10 meter per second square because looking at these numbers, the value of 10 will give us the easy answers. Computing it, h1 comes out to be 75 meter. Okay. Simple and nice question. Similar question you'll get in checkpoint. You can give that a try yourself. Note it down, then we'll go further. Here is the next question, and it's important one. So I'm deriving it. You just pay attention. Suppose a ball is thrown straight up with the speed u as shown. It will go up and somewhere it will be momentarily at rest. And then from that level, it will fall back along the same straight line. But for sake of simplicity, I am showing it little bit displaced. Okay. Now, if we consider this height to be h, the ball will be at this height h how many times? Actually 2 times. Once while going up and second while coming down. Is it okay? This time we consider, let's say, as t1, and this moment of time we consider as t2. Then we have to prove that h is equal to g by 2 t1 t2. It's pretty important result. I request you to learn it because the next question can be directly solved using this result. So let's derive it. For calculation purpose, I am assigning this as the positive direction, this as the negative direction. Acceleration due to gravity is taken here downwards. We are using here the second equation of motion. So we should be writing h is equal to ut minus half gt square. Do you agree? At any moment of time t, s is equal to ut plus half at square. So I am utilizing that. G is taken with the negative sign because it was in the downward direction. Okay. Rearranging the terms and rewriting the equations. G by 2 t square minus ut plus h is equal to 0. Is it a quadratic equation? Yes. Now we need the multiplication t1 and t2. This quadratic equation will have two roots of time, namely t1 and t2. And how we can find the multiplication of the roots? You remember the formulas of solving the quadratic equation. If it has two roots t1 and t2, their multiplication will be equal to h divided by g by 2. Okay, I am writing that if you don't remember. If we have a quadratic equation like this, ax square plus bx plus c is equal to 0, and this has two roots x1 and x2, their multiplication will be equal to c by a. This lies in the video of the mathematical tools. You can check it there. So we got our answer, h is equal to g by 2 t1 t2. I'll tell you the usability of this expression. Suppose there is a power line and you want to determine the height of that power line. It can be done simply by throwing a stone and noting down the time using the watch. How? Suppose you throw the stone up and then it crosses the power line at time t1. Stone goes up further and then attains momentarily rest, and then stone falls back. While falling back, it will again cross the power line at the moment t2. So you put here t1, you put here t2, you'll get the answer. Done? Note it down, then I'll be taking a question on this. It's a simple formula based question. The formula we have already derived, so I request you to give it a try. Then I'll be simplifying all the parts. Okay, the first part is the simplest one. As we already know the formula, for computation purpose, I am putting g as 10, t1 is 1, t2 is 3. So this comes out to be 15 meter. So the power line is at a height of 15 meter from the ground. Okay. The second part, what is the speed with which the stone was thrown up? That can easily be calculated. Try to imagine the diagram once. Suppose the stone is thrown up with the speed u. The stone crosses the power line at t is equal to 1 second and at t is equal to 3 seconds. While falling back, the stone crosses the power line. Let's say somewhere here is the power line. if you look at the symmetry of the time, t is equal to 1 second, t is equal to 3 second, the stone is at the same level. It means at which moment the stone attains its maximum height. Anyone can answer it now. T is equal to 2 second, the velocity of the stone will be momentarily 0. You remember the free fall has the symmetry. This time interval is 1 second while going up, then this time interval will also be 1 second while coming down by the same distance. So this is the maximum height of the stone above the ground. Now for the stone I am using the first equation of motion, and we are applying the first equation of motion starting from t is equal to 0 to this moment t is equal to 2 second. So final velocity will become 0 at t is equal to 2 second. Initial velocity is unknown. Acceleration due to gravity has been taken as 10 meter per second square, and for calculation purpose we are taking the downward direction as negative and upward as positive. That's why u had the positive sign because it is in upward direction, and the g is placed with the negative sign, and then t. V is equal to u plus at. You remember that format. T will be equal to actually 2 second. So u comes out to be 20 meter per second. It means the stone is projected up with the speed of 20 meter per second. Clear? And now we can easily compute this maximum height of the stone, which is equal to u square by 2g. Value of u is already available, so answer comes out to be 20 meter. The power line is at a height of 15 meter and the stone goes 5 meter above that power line. Okay, simple and nice question. You can note it down, then we'll go further. It's a very famous problem, and I'll give you 4 different methods to solve this particular question. It's important one, so I urge you pause here and give it your best shot. I hope you got your answer, so I'm deriving the things here. Suppose this is a tower of height small h. At t is equal to 0, ball A is thrown straight up with the speed u. It will rise and then it will fall back along the same line, but for sake of simplicity, I am showing the downward motion along a displaced straight line. It hits the ground at time t1. Simultaneously, ball B is projected straight down with the same speed u. It hits the ground at time t2, and the third ball C is just released. So its initial velocity will be 0 and it reaches to the ground in time t. We have to prove that t is equal to root t1 t2. Okay, that's our target. First, I am taking up the smartest method, the fastest method, so naming it M1. We know one relation. Suppose a ball is thrown up with the speed u0. It goes up and then it falls back, and I take up a particular height, let's say h. This ball will be at a height h how many times during its journey? 2 times. Once while going up and the second while coming down. Suppose at this level the speed is u. We know it by symmetry. Is it okay? And I take up this time as t2 and this time as t1. Do you remember something? Correct. We have proved it in this video that h will be equal to g by 2 t1 t2. Is it okay? Now, suppose a ball is just released and it covers a distance h as shown. then this time will be equal to root 2h by g. There is a complete video on that, objects dropped or released. You can check that. So we have two relations, relation 1 and relation 2. Use them. What you will get? By this equation and this equation, if you do the calculations, I am putting here the value of h. H will be equal to half gt square. From here you can obtain h is equal to half gt square. Okay, is equal to g by 2 t1 t2. The g by 2 here is getting cancelled out, so we are left with what? T is equal to root t1 t2. The most brilliant method to obtain this answer. Although I'll be solving this question again with 3 different methods. You note down the method 1, then we'll go further. Now, taking up the second method of the calculation, pay attention. I am taking up the ball A again. It is thrown up with the speed u. Okay, it will go up to its maximum height and then will return back to the ground. When the ball A is moving down, at this level its speed will be u. Do you agree? And if I compare now its motion with the ball B, it will take up the same time in traveling this h. Means I want to say this time is t2. Then how much is this time? t1 minus t2, because the total time was t1 for the motion of the ball A. Do you agree? If this time is t1 minus t2, then how much is the time taken by the ball A to rise to its maximum height? That will be equal to t1 minus t2 by 2. Do you agree? There is a symmetry in the time as well as the speed while going up as well as while coming down. Done? Now for ball A, I am using the first equation of motion. At the top of its path, its velocity is 0. For computation purpose, I'll be taking up the upward direction positive, downward as negative, acceleration due to gravity is in this direction. Use the first equation of motion, v is equal to u plus at. Final velocity becomes 0. Initial velocity is u in the upward direction, so positive sign. Acceleration due to gravity is in downward direction, so negative sign, minus g, and the time will be taken as t1 minus t2 by 2. Okay, this computation will provide us the value of u is equal to g by 2 t1 minus t2. Do you agree? Now I am taking up the ball B. For ball B, we are using the second equation of motion. S is equal to ut plus half at square. The displacement of ball B is in the downward direction, so will be written as minus h. I am putting that value here. The u of the ball B is also in the downward direction, so a negative sign here, and the value of u is available, g by 2 t1 minus t2, and then time taken by the ball B is t2. Is it okay? Plus half, the acceleration is minus g, and the ball B will take time t2. Fine. Okay, now I am using the second equation for ball C. The ball C is falling down. We are using S is equal to ut plus half at square. At the place of S, we will write minus h. U is 0. Acceleration is minus g, and the time is t only. Is it okay? So from this computation, h can be written as half gt square here, At the place of h, I am putting half gt square, and I am simplifying this RHS minus g by 2 t1 t2 plus g by 2 t2 square minus g by 2 t2 square. See, this g by 2 t2 square and g by 2 t2 square is getting cancelled out. This negative sign is also getting cancelled out. This g by 2 and this g by 2 is also getting cancelled out. What we are left with? T is equal to root t1 t2. Check it once. We have obtained the required answer. See, another brilliant way to obtain the same answer. I hope you understand it. Note it down. Now, taking up the third method, for ball A, use the second equation of the motion. What we should write then? Downward direction we are taking as negative, acceleration due to gravity is g. So it should be minus h is equal to u t1 plus half of minus g t1 whole square. Do you agree? So I am dividing by minus t1 every side. So it is h by t1 is equal to minus u plus g by 2 t1. We call it equation number 1. Now for ball B, again use the second equation. Speak up what we should write for ball B. Minus h is equal to minus u t2 plus half minus g into t2 square. Divide by t2 everywhere. So h by t2 is equal to u plus g by 2 t2. We call this as equation number 2. This minus sign automatically got cancelled out. Okay. I am adding up these two equations by equation 1 plus 2. What we are getting in LHS? H 1 by t1 plus 1 by t2. And what we are getting in RHS? This u is getting cancelled out. We are left with g by 2 t1 plus t2. Is it okay? Simplifying it further, from second equation for ball C, what we can write? That h is equal to half gt square. So put up that value here, half gt square. Simplify this bracket, t1 plus t2 divided by t1 t2 is equal to g by 2 t1 plus t2. Do you agree? I think now you can see the answer. This g by 2 is getting cancelled out. This t1 plus t2 and t1 plus t2 is getting cancelled out. T square is equal to t1 t2, or t comes out to be root t1 t2. Same answer but a different approach. You note it down, then I'll be taking up the fourth approach that is bit lengthy, but we'll go through that. Enjoy it. Now taking up the fourth method for solving the same problem, pay attention. I'm using the second equation of motion for ball A. What we should be writing? Minus h is equal to u t1 plus half minus g into t1 square. Correct? It's a quadratic equation. G by 2 t1 square minus u t1 minus h is equal to 0. Okay. Let us simplify this quadratic equation for its roots. So t1 will be equal to minus of minus u plus minus root of minus u whole square minus 4 into g by 2 into minus h divided by 2 into g by 2. This will give us the t1, which comes out to be u plus root of u square plus 2gh divided by g. Why we are discarding the negative sign here? The time interval t1 cannot be negative. This is a time interval, it should come out to be positive, so this should be the answer. Now I'll be using the second equation of motion for ball B. Speak up what we should write. Minus h is equal to minus ut2 plus half minus g into t2 square. This negative sign we can cancel out everywhere, and I'm rearranging the equation now. G by 2 t2 square plus ut2 minus h is equal to 0. Do you agree? Now solving this expression will get the value of t2. I'm leaving that to you. Do your computations. You'll get t2 as minus u plus root of u square plus 2gh divided by g. Okay, we have t1 as well as we have the t2. Now I'm multiplying them, and value of h I can submit from here. So t1 t2 is equal to 2 by g. H is half gt square from here. Okay, this g by 2 and this data is getting cancelled out. I think we are getting the same answer again. Can it be solved in few more ways? I'm leaving that part to you. Try to discover new ways of solving the same problem if you can. So this is all about this question from my side. I hope you enjoyed the question. Now you note it down, and then I'll be taking up the last question of this video. Here is the last problem of this video. Till now in every problem we neglected the air resistance. What if we consider the air resistance? This problem relates those things. So I request you to pause here and give it a try once, and then I'll be simplifying everything. I hope you are done with your calculation. So I'm simplifying the question. We'll solve it in two separate parts, the upward journey and the downward journey. So the upward journey we are considering here. The ball is thrown up with the speed u as shown. For calculation purpose, upward direction we are choosing positive, downward we are taking as negative. Acceleration due to gravity is in this direction. Okay, since in this case we have to count the effect of air resistance also, and while the ball is going up, air resistance will try to slow it down. So the effect of the air resistance is written like this. Do you agree? This slowing down ball will attain momentarily rest somewhere. This height we take up as h above the ground. So I'm using here the second equation of motion in the format s is equal to vt minus half at square. Why we are using that format? We know that v is 0, so this part will vanish. It will make your calculations quick. The displacement s is written as h in the positive direction is equal to minus half. The acceleration is in the downward direction, so minus g plus f, and multiplied with time of ascent square. This gives us the time of ascent is equal to root 2h by g plus f. Okay, keep it with you. Now I'm using the third equation of motion. It will give you 0 square is equal to u square plus 2 into minus g plus f multiplied with h. Do you agree? V square is equal to u square plus 2. Acceleration was in the downward direction. Downward direction has been chosen as negative. This provides us h, which will be equal to u square by 2 g plus f. Now will be writing the same equations for the downward journey also. For downward journey, ball is starting from this top position and let's say it's traveling a distance h, and while hitting the ground its speed is v. Okay. For this calculation purpose, I am choosing the downward direction to be positive, the upward direction to be negative. Acceleration due to gravity is in this direction. When the ball is moving down, air resistance will try to oppose its motion. So its effect I'll show like this. Air resistance has an effect in the upward direction, and upward direction we have chosen as negative. Gravity will try to speed it up. Okay. Now I'll be using again the second equation of motion, S is equal to ut plus half at square for the downward journey. Why we are using this format at this moment of time? Because we know that u is 0 in this case. So this part will vanish. Downward direction has been taken as positive. So S will be taken as h with a positive sign is equal to half. Acceleration will be taken as g minus f, and then time of descent square. So the time of descent comes out to be root of 2h by g minus f. Note it down. You can easily compare the time of ascent and time of descent. In this case, we can say the time of ascent is less as compared to the time of descent. Okay. Using the third equation of motion, the v square is equal to 0 square plus 2 g minus f into h. So v is equal to root 2 g minus f multiplied with the h. Value of h I am submitting from this calculation. So v is equal to 2 g minus f. At the place of h, I am putting u square by 2 g plus f. Do you agree? Here the 2 is getting cancelled out. So v comes out to be u root g minus f divided by g plus f. See the interesting thing. If we compare the things, we will come to know that v is smaller as compared to u. I am writing that information here. This I can explain logically also. Due to the air resistance, its motion is continuously retarding. Understand the thing? Air resistance is causing a loss in the energy. So when it will be reaching back to the ground, it will have less kinetic energy as compared to this moment. Okay. So v will be less than u. Now what if we go back to our ideal situation? There is no air resistance. If there is no air resistance, f is 0. If f is 0, you can check v will be equal to u. If f is 0, then time of ascent and time of descent will be equal. Getting it? So if we count the air resistance, the problem becomes bit complicated. Then for sake of simplicity in all the problems of free fall, we usually neglect the air resistance. Even in the next chapter, projectile motion, until unless something is mentioned, we will neglect the air resistance, and almost in every chapter of physics, whenever it is not mentioned, we will be neglecting the air resistance. Okay, note it down. I hope you enjoyed this lecture. Stay awesome. See you again.